I want to take a couple of minutes and discuss a particular issue that has come up, and I've already received 2-3 emails from students. And this is about homework number 3, and this concept holds for future homework also whenever solver is involved. Now, in this homework, now when you use solver to find the alpha value and minimize either the RMSE value or MAE value, okay, so what happens is some people are not getting the same answer as I have given in the answer key. So for example, suppose if I run this solver with MAE as the set objective cell, okay, and I say solve, and I get an answer for alpha, right? And of course that is going to determine what the answers for RMSE will be, MAE will be, and so on. So I've just copied that here. Okay, now we started with alpha equal to 0.3 and we ran the solver. Okay, suppose if I start with alpha equal to 0.2 and I run same solver, okay. So now this time the starting value is 0.2, and when I solve, now you see the alpha that solver finds is different from the one that we found earlier. Then all your other answers would be different from the answer key. So why is this happening? Now for that we have to understand what is called global optimum and local optimum. I'll try to illustrate that with a very simple example. Okay, so here, suppose if this is the way the RMSE value or MAE value changes over the value of alpha, and when you have non-linear, that is G or G non-linear that we selected in solver, this is one possibility. What solver does is wherever it starts from, suppose if we want to minimize, right? We want to minimize the value of RMSE or MAE, then it will check. Suppose if this is the place where we are starting from, okay, alpha being here, it will see whether reducing the alpha value reduces RMSE or not, or increasing the alpha value reduces RMSE. So here, decreasing the value will increase the value of RMSE, increasing the value of alpha will decrease RMSE. So it will start searching for a minimum value by increasing the alpha slowly, and as the RMSE comes down and down and down, at some point it starts to go back up. So what solver will do is it will stop right there and use that alpha as the best alpha. But that's only a local minimum. The global minimum is right here. This is the smallest possible RMSE value. Okay. Suppose if the beginning value of alpha in solver had been here, somewhere here, then again decreasing the value of alpha will increase the value of RMSE, whereas increasing the value will decrease the RMSE. So it will start increasing the value of alpha and it will find this point, and that would be the global optimum. Okay, so we actually don't know whether we started from here or from there, whether we found a local optimum or a global optimum. This is the reason why when we have a non-linear problem, we should usually try to use different starting points. So maybe one alpha from here, one alpha from here, one alpha from here, one alpha from here, and then see which starting point gives you the smallest possible value for RMSE. This is the reason why some students are getting different values than what I have provided as the key. So this concept is actually a management science concept. That's why I did not discuss this in this class. But for the moment, what I have done is I have redone the answers in such a way that if you have a starting value of 0.3 or 0.2 or whatever that was given, so in this particular problem it is 0.3, then I have given the answer key for all the answers based on that 0.3. So what I would suggest that you do is you set up everything with that point 3, okay, don't run solver until you have set up everything and you have checked the answers and everything is fine, and then after that you go back and do the solver, and that way before you start the solver you know you have set the model up and complete the complete worksheet up correctly.